Welcome back, students. Today we're going to be talking about functions. Now, in order to understand functions, first we need to talk about a relation. A relation, all it does is it pairs inputs with outputs. Okay, so think of an ordered pair. An ordered pair is when you've got the parentheses and then an x and y value. Now, the x-coordinate is the input. The y-coordinate is the output. So anytime you've got that relation where in this variable, we're taking in an input, in that variable, we've got an output, it's going to be called a relation. Now, a relation that pairs each input with only one output, okay, that's what we call a function. Okay, so a function means that every single possible input has only one possible output that goes with it. Okay, so determining whether or not relations are functions. We're going to see several different styles of looking at a relation, and then we're going to use that one definition that each input has only one output in order to identify if it's a function. All right, so first we got a bunch of ordered pairs. Now, the input of -3 has the output of 4. Now, I don't see any other -3's, so that is its only output. So there is only one output. If the input was -2, output is 4. If the input is -1, the output is 4. Now, even though this 4 is repeating, remember the definition. Each input has only one output. Well, -1, it only has one output. The output is 4. 0 has only one output. The output is 4. So this is a function. Each input has only one output. All right, now here, if I were to say, if the input is 2, what's the output? You'd say 4. There's only one answer. If the input is 3, what's the output? 5. There's only one answer. If I were to say, if the input is 1, what is the output? You could say 3, or you could also say 5. This has two different answers. The input of 1 has two different outputs. Therefore, this is not a function. All right, now we're going to move away from ordered pairs to a table. If the input was 0, the output is 0. If the input is 2, the output is 1. Input is 4, the output is 2. Now, in every single situation here, we notice that for any number x, there's only one output that it's going to. So this is a function. All right, now here, once again, we want to ask ourselves, is there an input that has more than one output? Well, just look here at 2. If we input a 2, we could get a -4 or we could get a -6. This input has two different outputs, therefore it is not a function. Now, this is the graphical form. Very much we still need to be thinking in the exact same way. If x is a -5, how many outputs are there? There's 1. The output is going to be 2. If the input was -4, output is 3. If the input is -3, the output is 4. Notice I'm just looking at these numbers along the x-axis and then seeing where the dots are, and that's the output. So where that dot is, that's the output for that particular input. Now, there's an even easier way to think about this, okay? And that's the vertical line test. So a graph represents a function where no vertical line passes through more than one point on a graph. So it's going to be a function if no vertical line will cross more than once. So in this first example, notice as I move this vertical line, at no point did the vertical line touch more than one dot at a time. That makes this a function. In this next one, however, as we move this vertical line across, we reach this point where the vertical line does cross two dots. And what that means is that the input where x equals 2 has two different outputs, a 1 and a 3. So it is not a function. Now, it doesn't always have to have dots. It could be continuous curves. In this situation, and once again, remember, if the line just crosses twice, it's not a function. Pretty much everywhere that line was moving, it was crossing in two places. So this one is also not a function. Now that's the vertical line test. And vertical line test is once again just going along with that idea that each input, x, can only have one output, y. All right, so let's use vertical line test again. Remember, we're just going to think about drawing a vertical line that could go across, and if it only crosses once at any given point, then it's a function. If it can cross twice, it's not a function. So in this first one, we notice the vertical line only ever crossed once. So it's a function. All right, over here, we can see it's already crossing more than once. It's crossing twice, therefore, that one is not a function. Now, a function basically works like this. You put an input, in this case a -2, and you're going to put it in the x. So 3 times -2 would then give me the output y, and so out comes out the -6. Now, the domain of a function is a set of all the possible input values. So everything you could put in is part of the domain. The range is the set of all the possible output. Okay? Now, with this particular unit, there's a lot of vocabulary. We've been talking mostly about functions and relations so far. Function just has each input matching an output. We said that input was the x, output was the y. Here are two more words that you should try to associate with x and y. Domain is all of the x values. It's all of the input values. Range is all of the y values, or in other words, all of the output values. Go ahead and write that in your notes, but do something to link that in your brain, that x, input, and domain all go together. That range, output, and y all go together. All right, so let's find the domain and range from a graph. Now, in order to find the domain, first we need to find the lowest, we need to find all possible x values. Now, because this is a continuous line, I don't just have a value here at -1 and then another value at 0. I also have all of the numbers in between that -1 and 0. Anything that's on the curve is a possible solution here. So I need to use inequalities to show what it is. So I'm first going to find the smallest value, which is this -1. And the furthest forward we go in x is to a +3. Now what that means is that my domain has x being greater than or equal to the -1 and less than or equal to the -3. We say or equals to because both of those dots are filled in. We might be using just a less than if we noticed that one of the dots was not filled in. Now for the range, we're going to put in these lines. We notice that for the y values along this y-axis, we go from -3 to as high as 2. So the range is going to be -3 is less than or equal to y, which is less than or equal to 2. That's all the potential values of y. Now this is how you're going to do it if the graph is continuous. Now if it's discrete, meaning it just has single dots, we're going to find the domain by identifying each individual x value. So we have an x value at -3, at -1, at 1, and at 3. So that creates a domain. We're going to put it in curly brackets, and we just write out each number, -3, -1, 1, and 3. There's the domain. For the range, we repeat. This time we're going to be focused in on the y-axis. So at -3, at 1, -1, 1, and 3. So our range is going to be -3, -1, 1, and 3. right, so even more words. Okay, the variable that represents the input values of a function is called the independent variable. So we just said this is input. Independent is input, which also means that it must go with x, which also means that all the values of the independent variable must be the domain. Make sure that you're linking all of these words together. The variable that represents the output values of a function is the dependent. So this is the y. Now, the reason why we call it the dependent variable is because it depends on the value of the independent variable. Okay, so if you were to ask someone, how much money do you make a week? And they say, well, that depends on how many hours I work. They are giving this statement of independent and dependent relationship. Their income is dependent upon their hours worked. Now, when an equation represents a function, the dependent variable is defined in terms of the independent variable. And we'll look at more what that means when we write an equation. But if you remember from the video on solving formulas and rewriting formulas, we talked about how you solve for one variable and then it's in terms of the other. So if you don't quite remember that, you could go back to that video, give it a quick look over. So the statement y is a function of x means that y varies depending on the value of x. Just like someone's income. If they worked more that week, if they worked more hours, then they will make more money. How much money they're making is varying depending upon whatever their input value of hours is. So, identifying independent and dependent variables. Here we got this function, c equals 6t plus 8. It represents the cost c for t-shirt shipping. All right, so t is how many t-shirts, c is the cost for shipping those t-shirts. Now, we want to identify the independent and dependent variables. The cost is going to depend upon the number of t-shirts you buy. Okay, so C cost, notice it's the one that's dependent upon the other. C is going to be our dependent, which means our independent variable is T, the number of t-shirts that are bought. And our dependent will then be C. Okay, now this equation right here is a function C in terms of T. So we have C is solved for, and T is the variable on the other side that creates that variation. That as T goes up, C will go up. As T goes down, C will go down. Now, if the domain is 1, 2, 3, 4, 5, remember domain. Domain is always linked to the independent variable. Okay? So if the independent variable can be 1, 2, 3, 4, and 5, then what is the range? Range went with the dependent variable. Okay, so essentially what they're doing, they're giving us values for t, and they want us to find what are all the values of c. So that's what I've done right down here. I took this 1 and I put it into the equation. I replaced t with a 1. And then I found out that if you buy 1 t-shirt, the cost is 14. If you buy 2 t-shirts, the cost is 20. If you buy 3 t-shirts, the cost is 26. 4 t-shirts, the cost is 32. 5 t-shirts, the cost is 38. And I'm going to stop right there because they said that the domain was 1, 2, 3, 4, 5. So those are the only numbers we would use in that equation. So now, to state the range is just going to be all of the output values. So 14, 20, 26, 32, 38. And that's the range. And that's how you find the range whenever they give you a domain to start with. I hope this has been helpful. Good luck.